Moving on with some more examples of radicals. So I note in number 1 and number 2, these are examples of the first type, which is where you have a radical equal to just a number. So you just have a single radical to deal with. If you square or cube or whatever both sides, you wind up with just a number raised to a power. The second type we're going to deal with is a radical equal to a radical. That's like number 3 or number 4. All right, so fold this under, and we'll be looking at number 3 in this video. If you haven't already written down the steps, you might want to pause the recording right now and write down those steps. All right, so first step is make sure that our radicals are isolated. Over on this side, I have a radical, and on this side, I have a radical. Neither one of them has anything added to them, or subtracted, or multiplied, or divided, so we're good. So the next step then is we want to raise them to a power. I do have to check and make sure that these radicals match. So this is a cube root, this is a cube root, that's good. If they were both square roots, that would be fine. If they're both the 10th root, that would be fine. But if this was a square root and this was a cube root, we couldn't solve it, at least not with the methods that we've learned. So as long as they match, we're good. And we want to raise both sides to that power. Now this type, where you have a radical equals to a radical, is actually the easiest, because when you do this, basically the radicals just disappear, and you just write down what is underneath each one. So I have negative 8 minus 2v equals 3v plus 37. Now I do have my variable on both sides of the equation. So as I solve it, this is a linear equation. For a linear equation, you want to get your x's or your variable, whatever, on one side and just numbers on the other side. That's the goal. So I want to move all of my variables to one side. I'm going to move them to the left. It really doesn't matter if you move them to the right. That's totally fine too. But to do that, I'm going to subtract 3v, which, yes, is going to give me a negative number of v. That's okay. So this will cancel. I have negative 8 minus 5v equals 37. I want to get something times my variable equals just a number. So I want to get all the numbers, the constants, over to the other side. So I want to get rid of this negative 8. I'm going to add 8 to both sides. That gives me negative 5v equals 45. Finally, I just divide. I have to divide by a negative 5 though, because that's what I have multiplying my variable. That's going to give me, when this cancels, I get v equals negative 9. All right? But I do have to check. So I'm going to have the cube root of negative 8 minus 2 times something equals the cube root of 3 times something plus 37. I know I'm kind of invading the space for number 4 here, but that's all right. You can do these on a separate sheet of paper if you need to. So what we're doing is we're checking to see, is this a true statement when I put in my solution? All right, it looks complicated, but really we just have to make sure that the thing underneath the radicals matches. So negative 8 and then negative 2 times negative 9. Negative 2 times negative 9 is positive 18. So this is cube root negative 8 plus 18. And over here I have cube root of, let's see, 3 times negative 9 is negative 27 plus 37. So I want to know, is that true? Well, this works out to the cube root of 10 equals the cube root of 10. Is that true? Well, I could totally plug these into a calculator. That would be no problem. I could do that. I could even probably figure out how to do it on Google if I didn't have a calculator handy. But I don't really need to. The fact is I'm taking the same root on both sides and I have the same number on the inside. So I'm done. I'm fine. Those two match, which means I can box this answer up. All right, number 4 is very similar. It's, again, a cube root, and you're going to be solving for x. So go ahead and give that a try. And remember to ask for help if you need it.